everybody. So in the 1970s, there was a famous Irish footballer, probably one of the first real sporting superstars, called George Best. And George was in a hotel room. He's lying there with a couple of supermodels. There's champagne, traces of cocaine. He's obviously having a wild party. And one of the staff of the hotel comes in, bringing food and room service. And he looks over at the bed and he says, George, where did it all go wrong? And so this talk, like one of my other talks, is in that spirit of, I definitely would be a celebrator of microservices, but I feel that some points when we look at it, we wonder why perhaps today there is a bit of a backlash against them, a call for us to return to the monolith, etc. So I'm going to try and dig into that and try and dig into practical help that you can have that may help you navigate the space. That's a lot of text that you can't read. That's because I'm old. That's really what that says. That's the summary version from ChatGPT. Ian is old. Are there any .NET developers at this conference? Oh, a few of you. Yay! I work on an open source messaging framework for .NET called Brighter. We compete with Mass Transit and N-Service Bus. We are actually similar sort of era, right? Okay, what are we going to talk about today? I want to get through some fundamentals and some definitions just so we are all kind of on the same page about the words we're using, because words, unfortunately, in semantic diffusion are at the heart of some of our problem. We'll then go into that problem a little bit. We'll talk about what seems to have gone wrong, and then I will offer you some pragmatic advice. It's 45 minutes, so a lot of that advice will be signposting rather than detail on some of that items. I suspect, given 45 minutes, Q&A will be brief. But the first thing I want to do is just run through what we might think of as some fundamental ideas that are important to us. Okay. There is a fundamental theorem of software engineering, and the fundamental theorem was defined by Edward Yordan and Larry Constantine in Structure Design in 1975. I am sure you all know it. That is the formula, one I'm sure you will recognize and regularly respond to when you're asked about it at an interview. Okay, just for those of you that may temporarily have forgotten the fundamental theory of software engineering, it says, due to complexity, it is always easier and cheaper to create two small pieces rather than one big piece if the two small pieces do the same job as the single piece. This is because combining two problems in one piece forces us to deal with the unneeded interactions between the two pieces. So I currently work at Just Eat Takeaway. So we might have, say, for example, the problem of how do I price a basket and how do I assign a courier to do delivery. It is pretty obviously going to be easier for us to solve those in two separate pieces rather than one piece and have an unnecessary level of coupling between those two pieces. So you can be more specific about that advice. Specifically, we suggest that the cost of implementing a computer system will be minimized when the parts of the problem are solvable separately, right? Two quite distinct problems that you solve, and manageably small. There's a slight addendum by Yordan and Constantine to note of manageably small. Everyone has a different definition of manageably small. To a large extent, that is just microservices. In 1975, we pretty much defined what microservices were, right? Break up a system into smaller pieces where those pieces are solvable separately and manageably small. And we've known since 1975 that that is how you reduce the costs of doing software development. It's the fundamental theorem. Let's define some other ideas, though, as we get into this and try and we'll figure out where we went wrong. So a module. So a module is a lexically contiguous sequence of program statements bounded by boundary elements and having an aggregate identifier, which I can't even say. But the easy version is it's a group of statements having a single name by which it can be referred to, right? So we're going to agree that's a definition of a module. So Martin Fowler's got a definition of a software component, which are things that are independently replaceable and upgradable. So you can think about libraries and you can think about services. And essentially, components are modules that are replaceable. And that replaceable is a key idea. And a service is a component that exists in its own process. Clients talk to over something to process communication mechanism, RPC, RESTful calls over HTTP, messaging, etc. Right? So for services to become a component, what that means must be that they have a requirement that they are replaceable. And generally what we want them to be able to do is replace that without impacting anything else. Right? So module, collection of code with a name. Component is one where effectively I can independently replace that module. And a service is one that essentially runs in its own process. It's a fairly simple set of definitions of what we're talking about. So James Lewis and Martin Fowler, both here, went on to define microservices. And arguably what you can think of as microservices are a set of practices for succeeding at this architectural style of building services, where we think about services as things that are replaceable, manageably small, and solvable separately. And of those properties, which are the ones they define in their article, the key ones we might want to think about for the purpose of this talk are componentization via services. That really says nothing other than those definitions we already gave. And the one we'll pick up a bit later, that it's organized around business capabilities, right? So we'll come back to that one. But the first point you should understand from modules, components, services. And there are some benefits which we suggest happen because of microservices. Strong module boundaries, because that process boundary is stronger than doing it in process. So our module, if it's defined as a library, it's fairly easy to kind of like violate that boundary, leading to the big ball of mud. But in theory, it's much harder to violate that boundary if we're actually going to cross a process boundary, right? Independent deployment, because we know that they are independently replaceable. We have said that's one of our characteristics of it being a service, right? And reduced cognitive load, the idea of code that fits in my head, because they are manageably small. Right, and we get some other properties which are important, fault tolerance, etc., but we're not going to talk about today so much. But they have costs, right? As soon as I create separate processes, I do distribution, and that always implies a cost. Some of that cost is operational complexity. I'm going to have to create more build scripts. I'm going to have to think about how I monitor my code. I'm going to have to some kind of inter-process communication like RPC or messaging, right? They're harder to verify, right? I can't probably spin up all of the microservices on my laptop and therefore figure out how to test things end to end. I've got questions about separate databases living in microservices and how I do BI and ML, right? And there are general skill issues. Lots of people come to us knowing how to write a simple website, but have no idea how to write a distributed system. And that tends to lead to this idea we call the microservices premium. You probably shouldn't be using microservices to solve your problems unless you are dealing with problems that are large. Okay? The code doesn't fit in your head. People can't manage to think about the amount of code that we've got. We've got probably, Amazon has a rule of thumb called the 2-pizza team, which basically is the maximum size for a team. Once it takes about 5 pizzas to feed everybody, probably you're a bit, and they're large American pizzas, not our small European. We have, we have cents pizzas. The subdomains have very different forces for change. So in other words, you've got something like, network busyness as a domain versus pricing your basket, right? Those two things don't change for the same reason, right? And they have a wide range of interactions. So more than just I'm talking to this website, but I've got mobile phones, I've got interop with third parties or other technologies. And so all of those complexity factors begin to trigger microservices as a solution. But you don't have those, then that premium may not be worth paying. And there's this general piece of advice, right? Okay. So what's the problem? What's happened? The quote actually is quite useful. From John Locke, who was a 16th century philosopher. Parents wonder why the streams are bitter when they themselves poison the fountain. So one of the problems is this word micro, right? So actually at GOTO, Fred George said, if it's more than one programmer to develop and design and maintain, it's not a microservice. They are very, very small. I mean, 100 lines of code is probably a big service these days. A single function microservices provide us with the highest degree of granularity. They increase granularity, give us more control over an application's resource, consumption, availability, and scalability. The problem, I think, is that micro has less to do with number of lines of code and the need for replaceability. And that kind of gets misunderstood. So small is useful in the sense that the bigger something becomes, the harder it gets to replace. But it's replaceability that we care about, not number of lines of code. The problem otherwise is usually described as nanoservices. So I don't know if you've seen these diagrams. Twitter produced one. Monzo, which is a UK challenger bank, produced one. We produced one at some point internally where I am. They look hideous when you have a nanoservices problem. Sometimes people provide them as badges of honor. Look at the amazing world I have to deal with, and all the rest of us look at it and go, look at the horror you've created for yourself. All right? So when you get, and quite often the order of magnitude we're talking here is 500, 1,000, 2,000 microservices, right? When you have that number, you get a huge set of problems. Every one of those services has integration points with other services that cross process boundaries, and those are potential points of failure. So if you have 2,000 microservices, you have 2,000 potential points of failure. You get increased latency if you tend to use an RPC style of interaction, which is typically what happens when you take your monolith and go, oh, there's a class over here and a class over here. I'll make them separate microservices. That's how you do it. And, I'll replace that local function call with a RPC call, right? And it, in turn, makes its own function calls. Well, great, that's RPC calls to the other class that I've now made a microservice, right? So there was a big argument on Twitter at some point during the hell of Twitter becoming X, where someone pointed out that to render your timeline took 64 calls, all kind of made in a chain. And you get huge problems of latency and reliability as soon as you get into that world. Right. High operational overhead. Every single one of those services is going to generate logs, is going to generate telemetry, and they're all going to be independent, and you have to find some way of stitching it back together to give yourself a view. Datadog will quite happily take your money to let you do that. It will cost you millions at scale that you will have to pay Datadog to do that. The question really is, did we solve a problem by letting Datadog do that by paying millions for it, or should we not have the problem in the first place? They tend to be basically in this form, very synchronous, RPC, temporally coupled. There's no bulkheads to failure. There's contagion. One thing goes down, it takes everything else with it. Ironically, for something where we think, well, I've created lots of little tiny services, surely I have loose coupling, actually you tend to have very poor cohesion because anything you want to achieve is actually divided across a large number of touch points, and you have high coupling as a result. You often end up with long release cycles because you end up in a shotgun surgery. Changing anything requires changing huge numbers of microservices. We have some kind of internal discussion about 26 touch points required to do X, right? And the problem it's pointing to is you have effectively fragmented your landscape, and it's no longer possible to solve a given business problem by simply touching one microservice. And they're a huge obstacle to reasoning. Once you get into 500, 1,000, 2,000 microservices, very few people in the organization have any idea how your system works anymore. And if you can't figure out how it works, it's very hard for you to reason about how you might successfully change it. So there's definitely confusion about micro, right? People are obsessed with size and not with replaceability, but what about services? Well, the problem with services is people have equated that to processes. Now, we defined services earlier, right? And although we talked about a process boundary, it was more to do with, hey, we're using process boundaries to help us effectively to create modules. But as soon as you equate that too closely, you get ideas like this. Each service is autonomous and self-contained and runs as a unique process. Each microservice is packaged as a Docker container to enable deployment in a Kubernetes cluster or application orchestration. A cloud-native application consists of discrete, reusable components that are known as microservices that are packaged in containers. And in the DevOps community, there is effectively a belief that a microservice is just something that runs in a container. Don't worry, Amazon also has got your back. Launched by AWS, Lambda is all that you need, basically, to build a microservice. So Lambdas, Kubernetes, pods, those are microservices, right? Doesn't seem like that's what we originally intended. So, anyway, any of you picked up on this? There was a bit of a storm because Amazon Prime Video, located in London, one of their team created a blog post which basically said, we have given up microservices, we've gone to a monolith. People didn't rashly think about the fact that Amazon probably hadn't gone to a monolith, that actually was one team within Amazon, but they'd gone from effectively 2 lambdas and 2 step functions to say, hey, we looked at this problem and we realized it's actually much more efficient if we run ourselves as a single process in Kubernetes. But the headlines were fairly extreme. It is clear that in practice, microservices pose perhaps the biggest siren song for needlessly complicating your system. The headline of DHH's post was, even Amazon can't make sense of serverless or microservices, right? Which is quite a lot, considering it's one team saying, we got rid of a couple of step functions and we made it a single process. Right. So I love team topologies, but team topologies sometimes seems to exist in a perfect organization where people do sensible things rather than kind of reality I live in. So they have this idea of fracture planes, very useful idea. How do we basically splinter the problem space that we are trying to basically deal with, right, our domain, into a number of pieces? So they have a number of different ways of developing fracture planes, and we'll come to the good way later. But typically, I tend to find there's another way they don't talk about, which is team availability, which says, we have a problem to solve. Who's not busy? Okay, they can build a microservice to do that work, and someone goes, but hang on a minute, isn't that just... No, that doesn't matter. It may be a variation of what that team's doing, but it doesn't matter. We'll just build something new over here, right? And you end up with these services. You go, what? Why do we have an entirely separate service that deals with the hours a restaurant is open compared to the rest of the information, basically, for a restaurant? Because that team was available. So that's the kind of reality you deal with, right? We don't necessarily live in a world where everything is perfect, and that kind of opportunity to use microservices to solve a problem of organizational capacity tends to lead to poor outcomes. So back to structured design in 1975, we had kind of an answer to all this, right? So the idea is, as I essentially increase the number of components and thereby reduce their size, because more components means each one is smaller to solve the same problem, I effectively reduce the number of what's called intramodule dependencies. So those dependencies effectively inside the module. I've got less lines of code. Obviously, I have less internal dependencies. And as I effectively increase the number of components, though, I will increase the number of intermodule dependencies, so the dependencies between things. So the problem we've got a lot with microservices today is people, when they focused on making them small, quite often cross over this point and keep going down. And what they're doing, unfortunately, is increasing the number of intermodule effects, and the cost, rather than being at this sweet spot, starts climbing again. And maybe, for a brief period, you were very excited about microservices, but then everyone's complaining about what happened. Please remember. All right. Is it fixable? Let me try and offer you some advice. So this quote is about the fact that people don't take advice. Some psychologists did a whole lot of work in the 60s, and basically the answer was, don't bother giving anyone advice, they don't like it. But I'll try anyway. All right. So I had a chat on a plane with Chris Simon. There's a link, we'll share the slides at some point after the conference, to a talk he did at DevOps. I was coming back from NDC Porto, and he was going back to Australia, but we were both flying back to Gatwick, where he was connecting. And I was explaining my thoughts about microservices, and I said, I just can't really figure out how to help people here. And he said, I've just done a talk about using the 4+1 view to explain how microservices work, and I think that could help you. So we had this chat on the plane, and this talk kind of has generated out that conversation. So I wanted to give a nod to him for this idea of framing it this way. All right, anyone never seen the 4+1 view? All right, we'll explain it as we go along. 4+1 view says when we're doing something like software architecture or any form of design, the problem is we're trying to think of it as one way of viewing something. And actually, there are 4 distinct ways we can think about something, right? Logically, development, process, and physical. We'll go with each one in turn. And if you actually think about things in those separate clusters, separate models for achieving different outcomes, it's very helpful. And the problem is often when we talk about something like microservices, we're unclear what we're doing in each one of these steps. So we'll talk about that. Scenarios should be fairly straightforward. So scenarios are basically where we're gathering the requirements. This is an example of a technique I quite like called domain storytelling. Domain storytelling to me is a kind of modern version of use cases. I kind of much prefer it to some other techniques that are out there. But what happens is you have actors, people who are doing something, you have work items, things they're doing something with, and activity is what are they doing. And you can kind of, with product owners, etc., easily map out what are the kind of key flows in the system. We also, though, include other kind of scenarios, the technical ones. So this is a chart from something called attribute-driven design, which is, if you like, the lightweight form of ATAM. And that's the thing you may hear about people talking about quality attributes, the usability, modifiability, testability of the system, and you define a set of scenarios, in other words, the kind of constraints you want, the non-functional requirements for the system. So both of those are kind of inputs. We're capturing what should the system do, both from a functional and a non-functional perspective, right? And usually we start up here at the logical box. And the logical box basically is the functional requirements, what the system should provide in terms of services to its users, decomposed into a set of key abstractions. So I think about this as typically we're thinking about our domain model. What is the problem space? What are we trying to do? And when we think about this kind of problem space, that's where what we want to start thinking about is how might I divide the problem space up? So it's usually best to try and align the software boundaries with the different business domain areas. So what are those business domain areas? So for example, I work basically in what we tend to call nowadays hyper-local delivery, which means basically delivering from a local store near you, food traditionally, but nowadays all sorts of goods under an hour, all right? So that's a big domain. How might we divide that up into usable bits we can think about? So often there are natural seams. So we work in a 3-sided market, right? So there's partners, customers, and couriers. So obviously at a very coarse-grained level, we might want those. And we think about how we move work between them. So we might want some domain or subdomain around fulfillment. And then we need to move money around. So we might want some domain around money, payments, finance, right? And then when I look at each one of those in turn, I might go, well, when I think about partners, I've got to think about things like information about the store, information about their catalog. And essentially, if I talk to an SME, I could probably begin to break down into things that they think of as separate subdomains. Domain storytelling, and I'll show you a little picture in a second, but it won't necessarily be insightful, but domain storytelling has a set of heuristics you can use after you've joined to the flows for figuring out what represents separate subdomains within the overall domain you've been modeling. And very traditionally, for Six Sigma people, value stream mapping, this idea effectively is slicing up into process steps, maybe one that you want to think about, right? So most of you probably stayed in a hotel. There is a thing called the guest life cycle. The guest life cycle is effectively a value stream that talks about the process of staying at a hotel, from hotel selection through guest check-in, through occupancy to check-out. There are a series of process steps that you go through. And you can think about operational flows. In other words, I want to stay at the hotel. And environmental flows, please stock the minibar ahead of my arrival, right? So all of those are useful techniques. So domain storytelling, for example, this is one of their examples, which is basically buying cinema tickets. We could easily, don't worry about the detail, go through this and ring fence where we think essentially there are the actions of people on work items tend to represent separate subdomains. It doesn't really matter what technique you use. Use whichever really you think works for you. But ultimately what you want to do is try and break up your domain model into useful subparts. Okay. As an aside, I don't tend to recommend event storming anymore because event storming I tend to find is very focused on entities or aggregates and tends to lead to what we call an entity service model where effectively it's very CRUD-based and I prefer to think in terms of processes instead. All right, but I've got my logical model. One of the things to be aware about my logical model is it will change. Right? The business will change. The business will decide to do new things, stop doing old things, try and change the way it does things. If you think about checking into your hotel, once upon a time you'd have got a physical key. Then later on you basically get a card, right? Nowadays you might even get a bit of check-in on your phone, right, to your access to your room and door. So some parts of it change. Interestingly enough, some parts of it are more stable. The process of check-in persists. It's just that the individual activities or tasks within that might change. But you will have to effectively constantly adjust your logical model for the changes to the business. Because tasks and activities change more slowly, if you're thinking about subdomain modeling, tend to stick towards the processes if you can, because we will probably be doing check-in when hell freezes over, but effectively just the way we do it. The activities and tasks within it may basically alter. But it's a constant gardening activity, right? You will never arrive at a point where you can say, I've done the domain model, we're good for the next 20 years, right? That's never going to happen. So that's important for later, right? Okay. It's okay. You just need to be this tall. So we take that idea and we tend to go towards the development branch. The development architecture focuses on the actual software module organization on the software development environment. The software is packaged into small chunks, program libraries or subsystems that can be developed by one or small number of developers. The subsystems are organized in a hierarchy of layers, each layer providing a narrow and well-defined interface to the layer above it. So this is the point where we want to start thinking about how are we going to break up that logical model we just created into microservices. This is the view that says, I want to organize this into into units of software for delivery. Remember our constraint earlier. The parts of the original problem must be solvable separately. So I think about that point there as the Goldilocks point, or the Goldilocks zone, if you like. That is the point we want to get to. And the problem is going to be that for any given business, exactly where that is going to differ. The point where effectively the number of components you have for the business problem you are solving is just about as low as you can get to reduce the intramodule dependencies without tipping over to get you intermodule dependencies will differ. So it's unfortunately it depends problem. I'll give you a tip of the one way I think may help us begin to find that. But at the minute, it's a bit of a suck it and see. And one of our experiences at the minute is people have to do it 2 or 3 times before they really find where that is. So typically, first wave of microservices is likely to be wrong. The other indicator here comes from people like Neil Ford, etc., in software architecture. The hard parts, they talk about this idea of disintegrators and integrators. So integrators are things that force you to move something into one whole. Things like ACID transactions, right? If a transaction needs to be ACID, you don't really want to do it over a process boundary. If you need to share data, how chatty a relationship of data is you need to share between these two processes. Are you moving that data unnecessarily? Right? Would you end up with shared code? Right? Even if you did that and packaged it up. So those things force you to become a whole. Things that break you apart. It's too big, I can't think about it. Right? Change comes from very different directions. So in team topologies, they talk about this idea of the business domain bounded context, which is a bit of a mouthful. So a bounded context is often misunderstood. Bounded contexts exist in this development view. A bounded context is a collection of people, process, and technology that deliver software. It is your code repositories, it is your schemas, it is the code, it is the conversation you have as a team, it is the members of the team. Right? And the idea is that group shares a view of a model. It's consistent within that boundary. The subdomain is the thing that you are modeling. In an ideal world, obviously, subdomains map to bounded context. But remember what we said. Domains shift. What the business does will change. And over time, what typically happens is bounded context and subdomains grow out of alignment, which you tend to think of as technical debt. That's part of the reason in domain-driven design. In the large-scale software sections of the book, we talk about basically exercises like context mapping, where one of our efforts is to recognize and address that drift. Right. So they are two quite separate concepts. But it is this phase where we decide the bounded contexts. And so typically, one of the first things we will try is to say, okay, do I have a nice simple model where effectively those domains that I identified, the subdomains identified in a logical step, neatly map to problems that look as though they are probably code that fits in my head and roughly solvable by a two-pizza team. If I have those nice sweet spots, they are ideal to be just a microservice, right? So code fits in my head, forces for change and replacement are cohesive. Probably any ACID requirements are entirely contained within the service boundary, right? It's an ideal microservice. And this is really what the original paper refers to when it talks about splitting up services organized around business capability, right? That's the ideal world. Wherever you have those, just say, thank you very much, and tick the box. The problem is, in reality, we find there are quite often more complex models. The code for the domain is actually a lot larger than one person can fit in their head. When I think about domains like courier assignment, which deal with things like network busyness, distance from restaurants, size and weight and load of the package, what type of vehicle you're driving, vehicle restrictions, the domain gets pretty complicated, right? And so the question becomes, maybe I need to split that up because it's too big for one person's head, or maybe I need to put more people on the problem. So how do I kind of decide which one of those two that I want to do, right? Well, one question is, could I find a seam that lets me split it up into multiple bounded contexts? If it turned out that checking into a hotel was really complicated, could I separate the bit that checks me in from the bit that generates my room key? It would seem fairly lightweight as interaction between the two, right? Because I'm just exchanging information about an identity and a room number. So I could look for these activities. And we said activities are more dangerous because they will change more regularly than processes. But I might be able to find activities within the subdomain that are separate. I want to watch for complex intermodule dependencies, right? And I want to make sure that those two activities are independently solvable. But I may create a dependency around transactions or shared data if I'm not careful about the way of doing it. So between that key and the check-in, probably there's no shared transaction. But I might have other scenarios where effectively I'm splitting an ACID transaction and I should avoid doing that, right? If I have multiple contexts, I now need to define the relationship between those contexts, all right? Okay. And I need to be careful about breaking up so low that I get nano services. If I can't break it up, what do I do? Well, typically what I might need to do is think about making it one thing and using modularity or components in process. So I don't reach for microservices. I say, actually, this needs to have modularity, but that modularity won't use a microservices approach. It will instead split it up into larger pieces. And that was named macroservices by Cindy Sridharhan. She said, effectively, let's call this idea macroservices. And macroservices are not a monolith, because you may have many macroservices in your organization. And if we think, well, our rule about breaking up our monolith is it's larger than a 5-pizza team, maybe there's some sweet spot between 2 pizzas and 5 pizzas. We deliberately use that measurement because it's not an exact number. where effectively we say, this is larger than a microservice, but it's not so large I necessarily am forced into breaking up to become basically a set of microservices out of the monolith. So I'm not creating a new monolith, I'm just creating something that's larger. There's going to be a cost to that. And the cost is those teams are going to have to work quite closely together, and we may get some release dependencies between them. So they may go a bit slower. They may need to have a mono repo. They may need to declare they've got a single CI boundary because they may be sharing data and maybe sharing across a schema. But in principle, the dependency management between them may become much easier than if I tried to break up what was a cohesive domain and was quite complicated across multiple processes. Because that process boundary I've introduced may cause me more pain than the problem effectively of having to coordinate release cycles across that team. And this is typically, I think, where some people struggle because they have said, well, these things must be 3 or 4 microservices. They then feel the pain and they say microservices doesn't work, I want to throw it all away and become a monolith. And what they really needed was somewhere in between, a bit like Prime Video where they went more into a macroservice. The other problem you can face, although it's less common than that one we just described, is where effectively your domains are tiny. And you may worry that effectively you're now going to generate huge overhead for one of these services being independent that isn't really justified by just making them fully independent. And you may say, okay, well, hang on a minute, I'd probably give 20 of these to this one team anyway, because the cognitive load of it's very small, and maybe they might find that organizing 20 of these things is actually a bit harder than actually trying to join them together. So could we look for ways to actually join them together in a single bounded context? Remember, a bounded context is not a domain, right? There is a mapping between domains and bounded context. They are not the same thing. All right, so we could basically say, okay, well, is this domain really independent? Does it have separate reasons to change? That's probably a bad candidate for joining together. But are the behaviors about the same work item? Well, maybe if we're just cooperating on the same work item, maybe we could be joined together. Are we talking to ourselves? So I've seen instances where there's 2 teams that own 2 tiny services and all they do is talk to each other. Well, why aren't you one thing? It may be that between these small things there's an ACID transaction. Well, we don't want to break that up. So maybe move them together into one service. Right. And will we weaken cohesion effectively if we treat them as a separate context? So maybe that's a good reason to pull them together. And if we leave them alone, will we suffer from the nanoservice problem? So sometimes your bounded context is actually multiple domains. Remember, we identified that our domains will change. So the problem here means that also means that the microservice partitions, the fracture planes that we choose, will change as well. Owning microservices is a constant activity. There is never a we are done. Right? Unfortunately, as your domain changes, you will have to repartition and change things. Hence, the requirement about replaceability. The more replaceable something is, the easier it's going to be to shift those boundaries. And actually, it's called out originally, when your components are services remote communications, then refactoring is much harder than within process libraries. So essentially, the things that you separate should be replaceable and quite distinct and focused on more process boundaries, right? And where things are tight together, maybe put them inside a macro service where it's easier to refactor them. I haven't got time to dive into it. I think one of the most interesting developments in this area, though, is Barry O'Reilly's residuality theory. If you haven't heard of Barry's stuff, you can check it out on YouTube. He's got a book on LeanPub. Barry, one of the things Barry's offering the promise of is the ability for us to effectively stress our models in order to see what kind of changes we can make to make them survive business changes in the future. So it works on the theory that we can cluster whole numbers of changes of producing the similar force for change on our service. So maybe we can produce something that better survives business changes. So his idea is he calls this a hyperliminal system, and essentially what he means in that complicated quote is the real world is messy, chaotic, and not easily structured. Software requires structure, requires, we have to be deterministic about it and is somewhat rigid. These two forces are in opposition to each other. We are trying to make a structure around something that is unstructured. And so it always breaks down in the end. But maybe we can figure out how it would break down and use that as basically a way of making something that's more resilient to those fractures over time. It's a very interesting field, but I haven't got time to go into more depth today. Okay. Some of this stuff is complicated. Processes. So processes are when we effectively take that bounded context which we have developed and we say, okay, how am I going to represent this in terms of processes? Processes are not bounded contexts. They are not subdomains. They are how we effectively create an executable unit for our software, right? It's a grouping of tasks that form an executable unit. Processes represent the level at which the process architecture can be tactically controlled, started, recovered, reconfigured, and shut down. Okay. It's also about how we interoperate. So in a modern world, we want to be application-centric, not infrastructure-centric. By that, I mean we care really about product development teams being able to say, here is my application, here are some things I need, platform provide them for me. Certainly at scale, you don't want teams to be having to deal with provisioning their own infrastructure, etc. That tends to mean you want to think about 12-factor apps, and we'll come back to that in a little bit. We also need them to communicate. You make some choices between asynchronous and synchronous. I would tend to choose asynchronous. Your mileage may vary. Even back in the day, people were carefully warned, microservices are not single processes. You may have more than one. When we look at 12-factor apps, there's some clear guidance, right? Effectively, you have diverse workloads. So figure out what other process types you have. So typically, you may have a web workload. A worker workload might be dealing, for example, with Kafka running in partitions. Your scaling of the worker that is reading from Kafka partitions is entirely dependent on queue theory and number of partitions. You are scaling for totally different reasons to the reason you are scaling the web component. Your Kubernetes web component may well scale on CPU, but you want to be scaling on queue length or latency for those one thing running against Kafka. You don't have one process. You divide it up into multiple processes, and that tends to be referred to as your process formation. There are some integrators and disintegrators here as well, very similar to what we had before. But essentially, if you think about a microservice ending up being a 12-factor app, and you think about a macroservice as being maybe one or two apps, or maybe some kind of microkernel architecture with plugins, and effectively both of those map to a process formation, not a process. And then we get to the easy bit, the physical bit. And the physical bit simply says, what I need to do is figure out how I put those processes into infrastructure. It's the point where infrastructure should emerge. And essentially, that's the point where you worry about Kubernetes and Lambda. All right. I'm done. I've got 2 minutes of questions.